Hi guys. So today we're going to look at complex numbers. So complex numbers are actually a really large number set. And what would be my number set? If you look at this picture, this may be something that you've seen parts of already. So if you look at the inside-most circle here, you have natural numbers. So that is the smallest number set. Those are whole positive numbers like 1, 27, 300. Then from natural numbers, we move to whole numbers, which is very similar, but we also include 0. Then the larger set from there is integers. So integers are still whole numbers, but they're both positive and negative. After integers, we move on to rational numbers, and this is one we're going to talk about a lot this year. So rational numbers are any number that can be written as a fraction. It doesn't have to be a fraction, it just has to have a fractional equivalent. So 0.9999 is a rational number because you can write that as 999 over 1,000. 7 is a rational number, and then of course any fraction, positive or negative. So something that is not a rational number would be a lot of those answers we've been getting from quadratic formula. So something like the square root of 3, 7 plus the square root of 7. That would be an irrational number because there's not an actual fraction that's comparable to it. Another example of an irrational number would be pi, and then another one that you'll learn later this year is e. So all of those numbers that we've done so far have fallen under the category of real numbers. But if you notice, a lot of times we'll write all real numbers as a solution. We don't just say all numbers, because there is a set of numbers that still is outside of real numbers. And that set is the set of imaginary numbers. And what that is our numbers that deal with the square root of a negative. So the imaginary I is basically the square root of -1. So what that means for us, whenever we're going to be solving these quadratics, if you get a negative under the square root, what we do is we move it to the front and we make it an I. So a negative under the square root is going to become an I. Another important property, if you square I, then you're going to get -1. So those are the two properties we're really going to use today to do some operations with these. Now, a complex number is really any of these number sets, but specifically the complex numbers we're going to talk about today will have an imaginary component. So standard form that we say for a complex number is in the form of a plus bi. A is the real part and b is the imaginary part. So something like 3 plus 5i, 3 is the real part, 5 is the imaginary component. So let's look at some examples. So to start, we're going to review some stuff about square roots. So if you remember with square roots, you can add and subtract square roots as long as they have the same number under the radical. So in this case they do, we can add those together and get 4 root 5. If you look at b in their current state, we can't add these together, but we can rewrite these values. So the square root of 8 becomes 2 root 2, the square root of 27 becomes 3 root 3, and the square root of 12 becomes 2 root 3. Then from there, we can combine those two together. We can combine these two together, and I get my final answer. So you cannot combine it any farther than that. They have to be the same number under the root in order to combine them together. Now, when you multiply, it's a different story. You can multiply any radicals together, but whenever you multiply, any numbers that are under the radical get multiplied and stay under. Any numbers that are outside the radical get multiplied and stay outside. So this would become the square root of 6. This would be -3 times root 2. All right, on D, again, we're going to FOIL this out. So 2 times 3. 2 times root 5. The 2 is outside, the 3 is inside. -3 root 3. Plus the 3 and the 5 can get multiplied together and stay on the inside. At this point, you can't combine it together any farther, so you would leave it. Then the last thing you learned about with radicals was in order to rationalize, you multiply by the conjugate. So 1 minus root 2, the conjugate of that would be 1 plus root 2. So we're going to multiply top and bottom by that. So that would be 3 plus 3 root 2. On the bottom, if I multiply that out, that would be 1 plus root 2 minus root 2. And then root 2 times root 2 is just 2. And what you'll notice about this now is those square roots of 2's cancel out. And that's intentional. The reason we chose to multiply by what's called the conjugate is because it creates that difference of squares, and those middle terms cancel out. So now from here, we can go ahead and simplify. So this is 3 plus 3 root 2. The bottom is going to be 1 minus 2, which is just negative 1. So I can simplify this to negative 3 minus 3 root 2. All right, so now let's go on to some complex numbers. So again, anytime we have a negative inside the square root, we make it an I outside the square root. So this would become I times the square root of 25. Well, 25 is the same. The square root of 25 is just plus or minus 5. So this would be plus or minus 5i. On b, the negative becomes an I outside. Square root of 20 simplifies. That becomes 2i root 5. 72, again, I times the square root of 72. 72 is divisible by 36. Since that's a perfect square, this would become 6i root 2. And then not all of these square roots will simplify. Sometimes you'll just leave it as something like this. All right, we already said I squared is going to be negative 1. I to the third, though, what we can think about, I to the third is the same thing as I squared times I. Well, we know that I squared is negative 1, so negative 1 times I is just a negative I. I to the fourth would be an I squared times I squared, which means it's negative 1 times negative 1. And negative 1 times negative 1 is just a positive 1. Well, now let's look at I to the 16th. I to the 16th, another way to write that would be I to the fourth to the fourth. I to the fourth is 1, and 1 to the fourth is still 1. So I to the 16th is still 1. So what's nice about this, that's going to be true anytime this number is a multiple of 4. So if that number is a multiple of 4, we're just going to get 1. So if I had I to the 80th, that would be 1. If I had I to the 200th, that would be 1. So now let's look at one that's not a multiple of 4, though. So what we want to do is we want to break this down and find the closest multiple of 4 to it. Well, in this case, that would be I to the 20th. So I to the 20th is a multiple of 4. So that means that's just 1. I to the third, we already know. I to the third is just negative I. So this simplifies all the way to negative I. All right, I to the 82nd. Again, that's close to I to the 80th. I to the 80th is just 1. I squared is all that's left, and I squared is negative 1. So on these types of questions, you really have 4 options. It's I, it's negative I, it's 1, or it's negative 1. And again, the easy way to remember it, I to the first is just I squared is negative 1, I to the third is negative I, and I to the fourth is positive 1. All right, so operations are actually pretty simple and very similar to what we've been doing. When you add and subtract, you keep the real parts together and you keep the imaginary parts together. So combine like terms. So this would be 6 plus I. When you subtract, just make sure you distribute that negative. So this would be negative 2 minus 3, which would be a negative 5. Then 5i minus negative 2i is really 5i plus 2i. So that would be plus 7i. When we FOIL, we'll go ahead and multiply. So negative 3i plus 3i is going to cancel out. I'm left with negative 9 plus I squared. But if you remember, we said I squared is just negative 1. So this simplifies even farther. All right, on D, again, go ahead and FOIL it out. And again, these middle terms cancel. Now, that's not always going to happen. We'll talk about why it does here in a second. So I'm left with 9 minus 16i squared would be the same thing as plus 16. So I'm left with 25. All right, then on E, in order to multiply this one out, let's go ahead and FOIL it. So that would be 6 plus 2i minus 15i minus 5i squared. Minus 5i squared would just be plus 5. So 6 plus 5 is 11. Combine the other like terms together, and I'm done. So the reason that that second one worked out the way it did and those middle terms canceled is because those were conjugates of each other, just like we talked about with square roots. And if you notice, that's a difference of squares. And in a difference of squares, those middle terms cancel. All right, on F, in order to multiply this out, we have one additional step to do first. We cannot just multiply these the way they are. We need to convert these to imaginary numbers before we multiply them. Then we can go ahead and FOIL. So this would be 6 minus 2i root 3 plus 3i root 2 minus I squared root 6. Minus I squared root 6 would just become plus root 6. So 6 plus root 6 is the real part. And then I'm going to put the minus 2i root 3 and the 3i root 2 together because that's the imaginary part. All right, so the last operation that we're going to look at is rationalizing. So in order to rationalize, we're going to use the complex conjugate. So the complex conjugate is like the conjugate that we used for square roots. We're trying to get that difference of squares. So if 3 minus 4i is in the denominator, then we're going to multiply by 3 plus 4i. I can go ahead and distribute. And then FOIL on the bottom. And then again, because we're multiplying by the conjugate, those middle terms will cancel out. Minus 16i squared is just the same as plus 16. So I have 30 plus 40i over 25. And then I can go ahead and reduce this, and I'm also going to write it in standard form. So 30 over 25 would be 6 over 5 plus 8 over 5i. All right, we'll go ahead and skip down to C. So again, multiply by the conjugate. FOIL it out. So that would be 6 minus 2i minus 3i plus I squared. At the bottom, 4. The middle terms will cancel, so I'll have minus I squared. Plus I squared would become minus 1 at the top, so that would be 6 minus 1, which is 5 minus 5i. At the bottom, that would become 4 plus 1, which would be 5. And then I can simplify and make this 1 minus I. On D, if you want, you can multiply by negative 3i, or you could also multiply by 3i, and you actually would still get a correct answer. But we'll go ahead and do negative 3i just because we're used to doing the conjugate. So that would be negative 9i plus 3i squared. Remember, I squared is negative 1. So this would be the same thing as negative 9i minus 3 and positive 9. I can reduce and simplify and make this negative 1/3 minus I. All right, and then on B, again, same thing. I just did that one last because it's got the radical. The conjugate would be 2 minus I root 3. And then I can go ahead and distribute. So 6 minus 3I root 3 at the top. On the bottom, again, those middle terms are going to cancel because it's a difference of squares. So I'll be left with 4 minus I squared times root 3 times root 3, which is just 3. So that would become 4 plus 3, so that would give me 7 at the bottom.